Hello, welcome back to the channel for another experiment connecting generative AI with analytics products for supply chain optimization. After the last video I did about this AI workflow connecting a mailbox to a production planning optimization tool that was packaged in a FastAPI microservice, I wanted to reiterate the experiment with now a more advanced agent that was able to call tools and take decisions based on the results. This is why today I will present to you my first experiment done with MCP Servers. The idea is to connect a Claude Desktop app equipped with the entropic models to one of my FastAPI microservice. This one is a supply chain network optimization tool, and ask multiple open questions to the agent and see how the agent is able to call the tools and answer the question based on the results. And to be honest with you, this is the first time I have been impressed by generative AI, and this is probably a pivot for us in our startup LogiGreen in the way we approach analytics products. So in this video, I will share with you the context and how the model is working. Then I will do a quick demo on the LogiGreen app with the web application interface. And then I will show you the type of analysis that the agent is able to perform. And to be honest, you will be impressed by the results. So maybe first I will introduce you the analytics products that we are going to connect to our conversational agent. So a demo is available in the LogiGreen apps. You go on sustainability and then you select supply chain optimization. Then you click on launch analysis and you are able to see the results in this tab. So maybe first, let me introduce you the context, what kind of problem we are trying to answer. Let's imagine that you are working for an international manufacturing company that has multiple markets. So here, 5 markets. For each market, you have a demand per month in units. And for that, to answer this demand, you can open 1 or 2 factories in each of the countries. For the factories, you have the choice between low capacity and high capacity factories. Each of these factories have production costs that are fixed depending on the size, but also variable depending on the country. So you can imagine that a country in India, for instance, has a lower production cost than in Japan. And then you have the freight cost between each of the factories and the markets. So this is from the cost side, but you have also to consider sustainability, where our company is called LogiGreen. For each of the factories, depending on the location and depending on the size, you have environmental impacts. So we have traced 4 of them, those CO2 emissions, the waste, the water usage, and the energy usage. And the idea is based on an objective function and some constraints, the algorithm will use linear programming to tell you what is the best setup in terms of factories. And you can select multiple objective functions. And depending on the functions, you will have different markets, like a different network design. So here, for instance, let me hide the tab here. If you want to try the app, this is publicly available. You have some explanation on the different objective functions. Here, the advanced parameters are still work in progress. But let's imagine that you want to minimize the production cost. You will have the results of the optimization. So you will have the total cost and fixed plus variable. And here you have the production flow. But probably if you look at the footprint in CO2 emissions or in water usage is pretty high. So you want to minimize CO2 emissions. So you can select the objective function CO2 emission. And what you will see is that the production costs will, the CO2 emissions, will decrease, but the cost will explode. And the difference and the flows will be different. So basically here, you are mainly localizing the production. And in these buttons, you can also select some additional constraints. So far, the constraints here are not changing the solutions, but you can put like a lower constraint in terms of water and see what would be the results in terms of production. And what you could see here is that now Japan production is a bit higher because probably their factories is better. So now you have what we can do with the user interface. But the main problem is, what if, for instance, I want to know what would be the most expensive setup? I need to test each of these objective functions. I need to change the constraints. And I don't want the decision makers to do that. So this is why we are trying to connect an AI, like a generative AI model. So here it will be Anthropic's Claude models, and to this analytics product to see if the AI can answer these questions by connecting to these tools. So let's try that. So before diving into the code and testing the tool, I wanted to show you what we want to do from a conceptual point of view. So first, we start with the Claude Desktop app. Why Claude? Is because MCP servers, which could be the equivalent of REST API protocol, have been invented by Claude, mother company, which is Anthropic. And for now, I mean, as a beginner, it's probably the easiest way to implement MCP servers because you can deploy them locally and you can play with it using a very simple, very user-friendly Python software development kit. So I start with a Claude Desktop. I create my MCP server, and I will show you quickly the code and how it looks like. And this MCP server will be connected to my FastAPI microservice. And what do we have in this FastAPI microservice? We have the input data. And we have some output data. So maybe let me go in details on the input data. So I will close the output. So the input, we have the objective function, like the different buttons that I showed you in the web application. So you can minimize the production cost, the water usage, the energy usage, or the CO2 emissions. And then you have some constraints, some additional constraints that you can add. So the water usage, so maximum water usage, maximum energy usage, and maximum waste generation. So in the previous example that I showed you, these constraints were so high that actually they were not additional constraints. But if you decide to put them, then you would activate the option in the FastAPI microservice, and then it would change the objective function. So for instance, that you want to minimize production costs, probably you will not have the lowest cost if you put a water usage that is higher than the best solution. So that's why when you are considering these constraints, this will affect the performance of your objective function. So this is the input data. So this is what the agent through the MCP server is supposed to send of a type of information to the FastAPI microservice. And then in terms of output, so let's just put ourselves in the shoes of the AI agent. The AI agent will receive some context via the way that you set up the MCP servers. It will be docstring that could be the equivalent of system prompts. But depending on the data, the agent doesn't know what the users have put in addition to the objective functions and the constraints. And here I didn't want, for the simplicity of the exercise, I didn't want to involve data upload locally. So that's why for the output, I also send the input data where I add the demand per market, the name of the different plants, factories, or countries. So here in that case, it's like Brazil, Japan, Germany, and all the two other countries which I forgot, and the objective function selected by the user with potentially also the constraint. I forgot to have put it here. And so this is the input data, but what's more important is the output data. So the results of the optimization. So in terms of cost, so here you will have the total cost, but also the cost per production country with the split between cost of production and cost of transportation, the environmental impacts. So here it would be the CO2 emissions, if you remember well, the CO2 emissions, the energy usage, the water usage, the waste generation, which doesn't have here an objective function, and the cost. And here the cost will be detailed split it between production and transportation, and we will have a concept of cost of goods sold, which basically takes all the costs between the factory to the market, which can depend on where you are sourcing your products, and the different logistic flows. So to explain basically to the agent how the network is looking, what is the results of this network design exercise. And based on that, we expect the agent to answer a kind of open question. So let's see how it works. So now we can dive into the code to understand how I have set up this MCP server, and then we can finish the video with the demo. So for you to understand quickly, I'm using the SDK of Python for the MCP servers. I won't enter into the details, but you can find in the description a complete article to understand how I have set up this environment. Here, this is a folder where I have one of my MCP servers. As you could see, I did multiple experiments. Here we are going to focus on the network design tool. But the idea is, so you define a MCP server. So here I define the MCP server called network server. I provide some information here. So the API address that I save in as an environment variable. I provide the HTTP address to call the FastAPI microservice. And then I define some variables. So here's a variable that I call last run. Why I have defined this variable is because what you will see in the demo is that to answer some specific questions, the agent can run one or multiple scenarios and then save that in memory and then combine the results to provide the correct answer. So I wanted to create this variable so the agent can store the last result in case he's needed. For instance, if he wants to reuse it for another question without having to recall the API, the FastAPI microservice. So what is interesting and why I wanted to show you the code is here what we put in the DOS string, we could be the equivalent of a system prompt that provides understanding to the agent on how to use the tool. And the idea here is to provide some context to the agent. So here we explain that it's a network design exercise, what the agent needs to prepare in terms of input data when to call the API, because here we are defining the tool, and then the expected output, a detail in terms of all the different fields, some examples, and then what kind of behavior we expect from the agent. Because here, what we want the agent to do is, based on the question, to call the microservice with the right inputs, collects the results, and then summarize them in a way that answer the question of the user. And I don't know what type of question it can receive. So that's why we need to make sure that the agent can understand the potential of the tool to answer these questions. Here, since I don't count the number of tokens, I have even provided an example. Probably the prompt that is detailed in the article linked below can be more concise, but here for the sake of the exercise, I provided examples. I did my best to make sure that the agent has all the keys to be able to do the job. And here below is just the function. So here we combine all the different parameters that are defined using this pydantic model, just to make sure that, so here you have the objective function, here all the different thresholds, just to make sure that when the agent is calling the FastAPI microservice, it's following the input data constraints that the API has. And then you call the API, you collect the results, and then these results are returned. And the saving of that is managed by Claude Desktop. Okay, so now that you have the context, we can start playing with our MCP server using Claude Desktop app. So for that, I will try just a simple request, which is please run the supply chain network optimization tool to minimize water usage. So now that it's loading, so here what you could see is that the tool is calling, the agent is calling the tool with the parameter objective function water usage. So which is based on the pydantic schema that I have introduced in the MCP server. And what you could see is the different outputs. So here, as I told you, first we retrieve the input parameters, so the objective functions, the max energy, max water, max waste, max CO2 emissions for production. So here, these are default values that will not impact the results, as I told you. Here, some units, I told you that I provide some context to the agent just for easy information. The different locations, so here, USA, Germany, Japan, Brazil, so number of locations. Probably this one is not mandatory. Then the different potential plants that you can open. So, you can open each location a low and high capacity. So that's why I'm listing here. This is for the context, for the agent to be able to answer the question. And then you have, and the total demand. And then you have the actual outputs. So first, the plant opening. So here, for each plant, we know we have the Boolean value at 1, and this is explained in the docstring, which is the equivalent of the system prompt. At 1 if it's open, at 0 if it's not. So here, for instance, for this result, for this objective function, we are opening a plant in the USA, in Germany, in Brazil, no, not in Brazil, a high capacity plant in the US, in Germany, in Japan, basically in all advanced countries. Then the flows, so I told you, between producing countries and markets. So you have 8,000 units that are locally produced for US, or you have USA that is producing for Japan, 12,000 units, blah, blah, blah. I won't enter in the details because it will be explained here. So then some KPIs, so the local production, the export production. Here, it's part of what we show in analysis in the web application, and I want the agent to also use that in his analysis of the results. The total production, the total fixed cost, variable cost. I told you we have some data for the cost, the units. And then some average figures that could be cost or environmental impact per unit produced. So the cost of goods sold, the unit energy and water. And here what you could see is that Claude model, so here we are using Sonnet 4, is using these results to provide a kind of a comprehensive explanation of the results. So what are the plants open? What are the key supply flows? Some performance metrics. So the consumption here, which is the objective function, the cost impact. Yeah, it's quite satisfying. But if you remember the video I did about this AI workflow for production planning, this is the result that we had. It's a kind of a workflow. We probably expect more now that we have equipped our conversational agent with the tool. So this is why I have started this new scenario, which is less than an instruction, but more than an open question. So let's imagine that the company that we are supporting is preparing a sustainability roadmap. They would like as a target to minimize their water usage. So what you could tell me is that, yeah, it's okay. You can select the objective function that is water consumption. But they also have some budget constraints. So here, what we could do, and we don't have here constraints of maximum budget to follow. We only have an objective function that would minimize it. So if I had to answer the question, what I would do is I would run multiple scenarios, putting some constraints on maximum water usage. And then I would take the best case that would meet this budget constraint. And this is what I expect the agent to do. And this is what the agent did when I asked the question. So here, let me just read the question. So starting from 2,632 liters per unit, what is the lowest consumption of water we can reach with a budget lower than 7 million euros? Please generate a dashboard to explain your answer. And probably this is here where I was impressed by MCP servers connected to Claude models. And here, as you could see, I used the Opus 4.1, which probably shows very high capacity of reasoning. So what the agent did? So first, he started to run the initial baseline with the water consumption of 2,600 and an objective of minimizing the water usage. Here, probably it's my fault. There is no point of running this one because if you put the constraint at that level, the minimization would be useless because the constraints are antagonistic. But it's okay. I don't blame the agent. Probably doesn't have enough information in the string. Then the water usage has been reduced. And here, this is where probably that I would question the approach of the agents. What I would do to limit the budget is I would take the objective function of production cost. But here, it took the decision of taking the objective function of water usage. Anyhow, I can see that the water usage is reduced. I mean, the constraint is reduced. So it's going up down to 2,500. What is the result? Oh, you got a result. Because we don't know, this is optimization. We don't know if we can get a result. Then it increased to 2,800, which is higher than the limit, the baseline that we have put. Then 2,900. I don't get the point, but anyhow, let's see later. Then up to 3,000. Then 3,100. And then 3,050. So here what we could see is that it seems that with this constraint, you couldn't respect the budget constraint. So it tried probably to increase the water usage, and that's why here I think it tested to see what happens if I reduce the constraint, because nothing is clear. I mean, except if you know the context that if you increase the constraint in terms of water usage, the cost will be lower because probably you are outsourcing to India or Brazil. But the agent doesn't know. So that's why I think it did this test. And I asked to have a dashboard. So let's see what you have in the dashboard. And this is where probably it's quite impressive. The results are quite impressive. So for me, what convinced me in the capabilities of the agent is this chart. Here you could see all the different tests that have been done by the agent. So this is the initial baseline that I gave. And what we could see is that it's over budget. And let's not forget, here I didn't provide any instruction of the type of visual that I was expected. And to be honest, it's pretty high quality. I would say even better than what I could produce in my web application. But here what you could see is that in the baseline, you are way higher than the budget constraint. And what I think the agent did is that it started to increase the consumption. Here, I think we don't see this scenario of 2,500. Why? Because there is no point. Probably the cost would be way higher. And he knew that if he reduced the limit below the baseline, the cost would be higher. So if the agent wants to meet the budget target, he probably has to increase this limit. That's what he did in the third one by running a test with 2,800. But what he could see is that the budget is slightly over than the limit. So he understood that probably he has to even increase the limit. And here he saw that now he's below budget limit, which is a good news. But except if you have the context, you don't know if you are further increasing the water consumption, what would happen. So I think he started to try with 3,000, and then he understood quite easily that the tendency was the higher the water consumption, the lower the budget is, even if we see that it's not quite linear. But with this chart, you can understand in one eye catch how the agent was reasoning. So he created then these different visuals. Here you have the budgets. I would say this visual is enough. But here you have a breakdown with the table, some strategic recommendation. I will share a public link to access all these dashboards so you can analyze the results yourself. But to be honest, this is where I have been impressed by this type of generative AI solutions, because the capabilities of the model to understand how to use the tool and to do the summarization, which is extremely important for decision makers, is probably where you can find the highest added value for that. And then I will not enter details, but it answering the question. Look, you capture 75% of maximum theoretical water while staying within the budget. It's exactly what I expect in terms of answers. And here you have a kind of a management summary, but what is more interesting is here, this visual and probably with this table. So this is the end of the demo. I will share other examples, or probably the video would be too long, but I did also another analysis that you can find in the article where I asked, that's this one, where I asked a dashboard comparing all the different scenarios of objective functions. So, and here you have a comparative results. To be honest, is quite high quality. I checked the results are good. So this is how I said like I said in the beginning of the video, this is a game changer for me. We are going probably to tend to have this kind of user interface for our analytics products because it is helping. I don't say it's replacing the decision-making process. If you have any question on how I implemented these MCP servers or the issues I faced, feel free to use the comment section and see you for the next video where I will show you another experiment I did connecting generative AI with analytics products for supply chain optimization.